Hello, everyone! Welcome to this tutorial on UModeler X. UModeler X is a tool that facilitates the creation of 3D content by providing functions such as 3D modeling, UV unwrapping, texture painting, and animation rigging for the Unity editor. This tutorial is designed for those who are new to UModeler X. In this tutorial, we will examine the various UModeler X functions and demonstrate how to use them, so that even first-time users can quickly become proficient. The order of the tutorial video is as follows. Let's get started. First, let's take a look at the basic interface of UModeler X. UModeler X's interface consists of icons that appear at the top of the scene view, and UModeler X components that are visible when a UModeler X object is created or selected. First, let's take a look at the icons at the top. Here, the UModeler Hub, Create UModeler X Object, and UModeler X Settings icons are displayed. If you click the UModeler Hub icon, the UModeler Hub will appear, where you can log in and out, or update the UModeler Hub and UModeler X versions. The next icon is the Create UModeler X Object icon, which allows you to create a new UModeler X object. When using UModeler X for the first time, you need to click this icon to create a UModeler X object. The next icon allows you to open the UModeler X settings window. You can change the color or size of the vertices, edges, and faces used in UModeler X, as well as configure the basic settings. If you create or select an object in UModeler X, element selection buttons will appear. Element selection buttons used to select vertices, edges, and faces, as well as object buttons to exit UModeler X object editing mode are displayed. In UModeler X, vertices, edges, and faces are collectively referred to as elements, and the selected element can be manipulated. Elements in UModeler X can be moved, rotated, and resized in the same manner as in the Unity editor. Finally, let's take a look at UModeler X components, which is displayed on the inspector window. Here, 3 modes and related tools for modeling, rigging, and painting, among other tasks, are provided. First, in modeling mode, mesh editing is the primary function, and the tools and properties related to editing and selection are categorized into groups. Rigging mode is an animation mode that contains tools for rigging processes like skinning. In painting mode, it is possible to add or modify textures and colors. Using layers and brushes, colors and textures can be modified quickly. Using the UModeler X interface in this manner, a number of 3D-related tasks can be performed directly within the Unity editor. Let's take a look at how to create a UModeler X object. UModeler X objects are configured to have an editable mesh by default. First, click the Create UModeler X Object button among the icons at the top of the scene. Then, on the inspector window of UModeler X component, select a figure-related tool from the Primitive Shapes group or a plane-related tool from the Drawing group. Here, you will select the Box tool in the Primitive Shapes group. After selecting, move the mouse cursor to the scene, click the scene, and drag without releasing the mouse button to create the box's base. When the desired bottom is reached, release the mouse button and move it upward to adjust the height of the box. If you wish to modify the size of the created box or the degree of face division, you can modify the displayed property values when the Box tool is selected. If you enter the property value directly, the change is immediately reflected in the scene. In addition to entering the property value directly, you can also locate the desired value by dragging next to the property name and modifying the value. When you have the desired shape, you can choose an element or another editing tool to complete the editing process. If you want to add another shape, you can click and drag the scene to create a new one. Now, let's look at the Drawing group in modeling mode. The Drawing group contains tools for drawing or adding flat shapes, like drawing edges, Here, I will select the disk tool. Similar to the box tool, the disk tool can be used by clicking and dragging to create a circular polygon. Here, you can use the line tool from the same group to create a polygon dividing edge. With the line tool selected, click an edge. And click another edge to divide the face. If you wish to divide the face further, you can click and then click another edge. Simply click the element selection icon or another tool when you're satisfied with the divisions you've made. So far, you have examined how to create basic shapes. As such, you can create a variety of basic shapes using the primitive shapes and drawing groups. Basic shapes and polygons can be used to create a variety of 3D expressions. But shapes can also be modified to create even more expressions. Now, let's examine how to manipulate 3D models using the editing tools in UModeler X. UModeler X includes editing tools for elements such as vertices, edges, and faces. First, use the selection icon at the top of the UModeler X interface to initially select the desired element tool among the vertex, edge, and face tools. After selecting the desired element tool, you can manipulate it by dragging a gizmo. If you select the vertex tool, you can change the model's shape by moving the model's vertices. By selecting the edge tool, you can modify the model's shape by repositioning, rotating, or resizing the model's lines. Finally, by selecting the face tool, you can manipulate the faces of your model to create complex shapes, or change shapes all at once. In modeling mode, in addition to the primitive shape group for creating figures and the drawing group for creating polygons, tools with various functions are grouped. Let's experiment with using various groups of tools to determine the meaning and characteristics of each group. Let's begin by examining the properties that are displayed when an element is selected. In modeling mode, element groups are at the top. When the element tool icon is clicked, the displayed properties vary depending on the element. Element groups have properties for how to display and select elements. By enabling the X-ray mode property while selecting a vertex, for instance, the faces become translucent, making it easier to see and work on the opposite side. In this state, when selecting vertices by dragging, the back vertices cannot be selected. If you enable the backface select property, you can also select the back vertices. If you want to select and move vertices based on their weights, you can adjust the weight of your edits by selecting Soft Selection in Soft Select. Alternately, you can change the shape of the weights to a soft selection curve or the range by modifying the soft selection range. All elements can use these properties for display and selection. Of course, some properties are restricted to specific elements. For instance, the smoothing group property allows you to determine whether the face surface is smooth only when the face tool is selected, and the extrude options property allows you to determine how the face is extruded. If multiple faces are selected and the smoothing group is set to 1, the selected faces will have a single smoothing group and appear smooth. It appears as if distinct groups are separated. However, they are not actually separated. The selection group is a collection of selection tools. Choosing the Isolate tool, for instance, selects all elements connected to the selected element. It is a tool that selects only the separated portion if it is not joined by a face. The Grow tool is a selection tool that expands the currently selected elements. You can select larger region than the selected one whenever you click the tool button. The Add group is a collection of tools that, when executed, add elements. Primarily, they add selected elements or elements determined by the tool. Using the bevel tool on an edge corresponding to a corner, for instance, will result in the addition of faces as the corner is rounded. The loop cut tool creates connected edges based on the edge closest to the mouse cursor to divide a face. As edges are added, the model can be edited in greater detail. The remove group is a collection of tools that delete elements when used. It consists primarily of tools that delete selected elements or combine elements. Due to the fact that combining elements reduces the total number of elements, they are placed in the remove group. As an example, since the target weld tool is a tool that merges vertices with other vertices, the total number of vertices is reduced. Real-time 3D content creation also requires optimization, so you can reduce the model's size and loading time by merging or removing vertices. The deform group is a collection of brush-style tools that deform the surface. Since the model is deformed using a brush, editing the model has a different feel than editing with gizmos. Using the move brush, for instance, you can deform vertices within a circle while moving them exactly as they appear on the screen. The surface group consists of surface tools. It primarily contains tools for vertex color and material settings, as well as the UV editor. For instance, the material tool allows you to apply a material to the selected faces, as well as add or remove existing materials. After navigating to the face tool in this manner, select faces to which the material will be applied and select the material tool. Here, if you add a material via the Add Material button, and then click the Assign button to apply the material to the selected faces, the material will be assigned to them. If you delete the applied material, the other material will be applied as it is. And if you delete the other material instead of the applied material, the added material will be applied to all faces. The Miss group is a collection of tools whose functions do not belong to any other group. If we take the Reset X Form tool and the Pivot to Center tool, which are frequently used when creating 3D models, as examples, the Reset X Form tool initializes the transforming position, rotation, and scale values of the selected object. If you want to directly reflect the rotation or resizing of a UModeler X object on the model, you can use the Reset X Form tool to do so. The Pivot to Center tool allows you to set the pivot position of an object and change the pivot to the object's center, top center, or bottom center. A pivot is a reference point used to position, rotate, or scale an object. It is the location of the object's origin, that is, the point of reference that defines the position of the gizmo and the position of each element in the object space. This is useful for shading or animating based on a pivot. As described so far, tools are grouped according to their characteristics. Groups make it simple to select the desired tool and enable rapid model modification. Now, let's examine how to modify a 3D model using UModeler X's modifier function. Modifiers are functions that alter the shape or structure of a 3D model by applying specific effects. Using the modifier system, UModeler X can transform the original model in a non-destructive manner. This system enables efficient modeling because changes can be applied to the model while the original model remains unchanged. UModeler X provides numerous modifiers that facilitate the modification of complex models. You can select the desired modifier and configure its settings in the modifier panel. The Bend modifier, for instance, can bend a 3D model into a curved shape. After selecting the Bend modifier, you can obtain the desired curve by adjusting the Bend modifier's angle and direction properties. If you directly selected model elements and made them curved, changing the degree of bending would require multiple tools and editing. Whereas using the modifier makes it simple to change the degree of bending. By utilizing the modifier function in this way, you can apply changes to the model more quickly and easily while preserving the original model. In UModeler X, rigging for animation can be performed in rigging mode. Rigging mode is used to animate the model, and weights can be assigned to the mesh and edited. Weight here means degree how much each vertex is affected by linked bones in animation. If the model element is a surface, the weight value indicates by what degree the bone movement is reflected in the vertex. The range of weight values is between 0.0 and 1.0. In the case of 0.0, the vertices do not move when the bone is moved, while in the case of 1.0, the corresponding vertices move together. Let's learn about rigging mode. For learning about rigging mode, you created a model shape and bones as shown. Bone structure EC created by adding empty game objects and to establish a hierarchy using them. To use rigging mode, you first need to configure to bones to use in the rigging task. The bone located at the top of the bones is inserted into the root bone slot, and the bone selected in this slot becomes the model's axis of rotation. After configuring, press Start Rigging to enter rigging mode. When entering rigging mode, an interface that's different from modeling mode is displayed. The bone tree is visible beneath the area where the top-level root bone is placed. In the bone tree area, you can view the bone structure assigned to the current model. The bone tree displays all interconnected bones, regardless of their assigned weight, and makes it simple to select the desired bone. Below this, there is a group of tools that can be used in rigging mode. I will assign vertices to the bones using the Weight tool. First, select a bone from the bone tree or scene area. You can either select the desired bone from the bone tree or select the bone directly from the scene. To instead select from the scene, enable clicking on Bones property. When you launch UModeler X for the first time, this property will already be checked. After selecting a bone, you can select the vertices you wish to move in relation to it. When rigging, the position of the vertex that attaches to the bone is typically close to the position of the bone to which it attaches. It would be desirable to connect this side's vertices to the selected bone. After selecting the vertices, click the desired weight value button under the Properties section of the selected Weight tool. You can set the weight in greater detail, but for now, I'm going to click the Weight button numbered 1. This will change the color of the edges that are connected to the vertices so that their assigned weight can be seen. We can move the bones more intuitively ourselves. Having selected the bone, let's move it using the gizmo. As you move it, the vertices to which you have assigned weights will move. If the vertex moves quickly when in moving it, assign a weight less than 1 to the desired vertex. Let's give this vertex between the bones an approximate value of 0.5. As before, clicking the 0.5 button results in a change in the amount of vertex movement. To reset the repositioned bones, you can use the Reset Pose tool. The bone will then return to its original position and rotation value. As you move the bones for the weights while rigging, you will typically check the vertex's assigned weight. The Reset Pose tool resets the position and rotation of a bone to its original default pose. Use the animation function in the Unity editor to apply animation. To access the Animation tab, navigate to the window menu from the top menu of the Unity editor and click Animation under Animation. I'm going to apply motion to bone 3 that I rigged here. Click the Create button to create an animation clip file in the specified location, then select the Keyframe Recording Mode button. In this state, if you move bone 3, you can see that its keyframes are registered in the Animation tab. Changing the frame or time above and repositioning bone 3 reveals that the keyframe is also registered here. When you exit recording mode and press the Play button, the animation will play. Thus, by utilizing rigging mode, you can rig without using any additional external tools, and you can use the Unity editor's features without interruption. Using the painting mode in UModeler X, it is easy to create textures in the Unity editor. In the painting mode, You can apply color to the model, and you can express colors and create textures using layers and brushes. To use painting mode, you must first complete the initial setup steps similar to rigging mode. However, since the default setting in painting mode allows you to begin painting right away, let's press the Start Painting button to enter painting mode. Painting mode is largely comprised of layer area, property area, and map source area. Beginning with the layers area, this area displays layers and tools for managing and editing layers. Layers are a concept used in a variety of image editing tools, and they consist of editable image layers. The layers overlap from top to bottom. Each layer's effect is calculated using a pre-applied color calculation formula known as blending mode, and then expressed as a single image. The property area is an area whose content varies based on the selected function. For example, whether it's a tool or layer, and displays the function's properties. It is comparable to the properties that appear beneath the selected tool, such as in modeling mode or rigging mode. However, since painting mode includes the concept of layers in addition to tools, it consists of areas that display properties for various functions as opposed to tool-specific properties. The map source area is a collection of properties for map source management, such as adding or removing map sources. It determines the resolution of the texture and the format of the map source. Here, map source is a concept used in the painting mode of UModeler X, and it refers to each individual property of a material, such as metallicity, color, and surface smoothness. It is a concept used in painting mode to edit and express multiple material properties, rather than a single texture in order to express a single material. Let's now try out painting mode. In this tutorial, you'll paint using simple layer types and properties. When you enter painting mode for the first time, you will notice that a painting layer has been created. A painting layer is a layer that enables direct painting on a model using a brush. Let's make some changes to the map sources. The properties displayed when a painting layer is selected are displayed in the Properties area. Here, if you change the color and click-drag the model's surface, you'll see that it is filled with color. Let's paint by modifying a map source other than the color map source. Let's change the metallicity property to 1. 1 means 100% and 0 means 0%. In other words, it has 100% metallicity. Smoothness below is the map source for smoothness. When set to 1, it is most smoothly expressed. In this condition, painting the surface reveals a very smooth metal surface. You can use a fill layer to fill the map source value of an area other than the painted area. Fill layer literally means an area filled with color. The fill layer's map source values are applied to all areas. You will incorporate texture into the color. Let's put stone block texture in the texture slot. If you insert a stone texture, it will be displayed immediately, but the texture appears not to be very dense. If you enter a value greater than 1 for the tiling property under Properties, the texture will become denser. You can use the layer mask function if you want to use a fill layer but still paint with a brush. A layer mask is a property that allows only a specific portion of an applied layer to be visible. For instance, you can create a second fill layer, select it, and press the Add Mask button. Choose the desired mask from the menu that appears. A black mask is a mask that does not display all of the properties of the layer to which it is applied, whereas a white mask displays all of the layer's properties. A layer mask can be painted with a brush, so efficiency should be considered when selecting a mask type. I will select black mask. Now, I will select the mask and paint the surface white with the brush. If you paint in white, you can see that the properties of the fill layer are expressed only in the white part. Using a fill layer and a painting layer, you can paint or fill multiple map sources, while a layer mask allows you to express only a specific area. If you want the texture to appear as though it were adhered to the surface, you can use a sticker layer. To add a texture to a sticker layer, click the Add Layer button. In addition, When you click on the model surface in the scene, the texture is applied to the surface. If the texture applied to the sticker layer has a transparent background, it can appear more like a sticker. This texture has a transparent background and only the logo is represented. However, what is actually being displayed appears to have a background. Due to the different map source values, if you disable the other map source by clicking its button, it will appear transparent. UModeler X utilizes the layer function in painting mode to improve the efficiency of texture work. Using layers and brushes, you can individually adjust the color, density, and roughness of a texture, as well as change their order to create a variety of effects. In this tutorial, we covered how to use UModeler X for 3D modeling, rigging, and texture painting. UModeler X is a powerful tool that can be used conveniently within the Unity editor, and it can be used in fields other than game development that use Unity. By using UModeler X in this way, a number of 3D-related tasks can be performed directly within the Unity editor. This enables the construction of an efficient working environment, as all tasks can be completed within Unity without the need for external tools. If you encounter any issues or have questions while using UModeler X, it is recommended that you consult the official documentation or the Discord server. Utilizing UModeler X's continually updated features will allow you to produce more diverse and creative work. We hope that UModeler X will be an invaluable tool for your game development and 3D content creation. Thank you.